Hey everybody. So one thing that I commonly do on this channel is I work on computer power supplies. While most computer technicians probably chunk these things in the garbage or e-waste whenever they quit working, I try to save them and keep them in service, as oftentimes what goes wrong with these things is failing capacitors or just stuff like that. But there's one thing about working on these things that makes me very anxious, and that's when it's time to plug it in after doing some testing or replacing some components inside the unit. It's very risky because there is a chance that you could have a short circuit inside the unit, and when you apply power to this unit, if there's no current limiting on that mains input power, it can be disastrous for the unit, and it can really stink up your workshop and things like that. It's not fun. I've blown up a few power supplies in my past, and yeah, it's not fun. So I'm going to show you how you can create a device that will limit mains inrush current and limit current in the event of a short circuit in one of these units like this, or any small electronic device that plugs into mains voltage that you are testing. Okay everybody, so in this video I'm going to be building a device which utilizes a traditional incandescent light bulb as a ballast. So what I've done here is I've went out and purchased some parts and also 3D printed a box. So all these parts here, like this switch plate, this light switch, and this electrical outlet, can all be found at your local hardware store. Now for this box, I 3D printed the box. Now you could actually use one off the shelf from your local hardware store, but since I have a 3D printer, I actually 3D printed this. Now I want to mention something, and this is really important. If you're doing electrical work in a house and you're needing boxes, do not 3D print your boxes, because in the event something goes wrong and the insurance company finds out that you 3D printed your box instead of buying a UL tested and certified box, they may deny you coverage. So just FYI, 3D printed boxes are not up to electrical code. However, for a project like this, it should be perfectly fine. Now I will mention, since we are building a device that will have mains power going through it, doing the steps in this video will be done at your own risk. I will not be responsible for any damages or injuries as a result of this video. That being said, let's go and get started. So again, we have the light switch, we have this wall socket, we have this switch plate or cover, we have the box which I 3D printed using an STL from the internet. For our ballast, we'll be using this light bulb, and to utilize our light bulb as a ballast, we will use this outlet to light socket adapter. So this just threads in just like that, and there you go. Okay everybody, so the first thing we're going to do is we're going to prepare this wall socket. What we need to do is we need to break this tab off on both sides. Normally this is left in place in normal use unless you are separating, let's say, L1 and L2 in, let's say, your kitchen, or if you're using one as a switched socket and the other as a constant on socket, you would break the live tab in that case. But in this case we're breaking both live and neutral, and I'm including this portion up front because it's important that we do this, otherwise you will have a short circuit. Okay, so I've broken the tab off, and it's important that you look carefully because there's actually two separate tabs in there that have to be broken to separate these two connections, and I've done that on both sides. And what we'll do is we'll go in this test to confirm using the meter that we have broken the connections. So as you can see, no noise from the meter on that one, and also check the other one. Same thing, that's what we want. Okay, so since I'll be using this device to test computer power supplies and maybe in some chances other small electronic devices that plug into mains power, we're going to sacrifice this computer power cord for this. So let's go ahead and cut off the end of this. And inside here you'll have three conductors. You'll have your live, your neutral, and your ground. Okay, so I'm going to use this crimper tool. I'm going to use the cutter in this to cut some jacket off of this wire. So that way we can expose more of the conductors inside, because we're going to be utilizing some of the wire that's in this. Okay everybody, so in this step of the video we're going to prepare our wires. So as you can see, I've already stripped these back, and this is stranded wire, by the way. So what I'm going to do is I'm going to tin these wires with solder to make them more rigid. That way they can be secured into place better on the light switch as well as the power socket. So I should note that the procedure I'm doing here, as well as the choice of wire, is not what you would use, let's say, if you're wiring a power socket or a light switch in your house. You want to make sure you follow all local and applicable codes for that. Now, of course, this is not part of my house's wiring, so there you have it. So anyways, let's go ahead and begin prepping our wires. I'm going to dip this wire in some solder paste flux, and what I'll do is I'll use a soldering iron. I'll preload some solder on here. I will then run across this wire. We'll make sure we have a relatively decent coating there. So anyways, I'm going to do this to the remaining wires, and we'll come back in just a moment. I forgot to mention that what you can do is, if you need extra wire, you can strip more of this back and get some extra wire. Now what I actually did was, I have a bunch of old wiring salvaged from, let's say, a refrigerator, and I'm just using that for this. It's roughly the same gauge, if not thicker, and it's rated for the applicable voltage. In this case, this wire is rated for 600 volts, so it's good to go. So you can do that, or if you wish, you can use, let's say, for example, Romex wiring. You just strip the jacket off, but that's of course a whole lot of work, and that solid core wire would be a pain to work with in something like this. And as I mentioned earlier, for example, if I'm replacing an electrical outlet, or if I am wiring a light or just whatever, I do use the proper wires that are required by code for the application. So anyways, it's going to continue on. Okay, so now I have went ahead and tinned the wires, and I've also bend them into a hook shape. That way we can attach them to the power receptacle as well as the switch. And I also have this ground wire pigtailed off of this here. That way this can go to the light switch ground, and this can go to the receptacle ground. And we also have two additional hot connections. This will jumper from the hot on the light switch, the switched portion. This will go into the bottom receptacle, hot side, or live. It'll pass through the light bulb, or through the socket rather, and on the neutral we're going to install this hot wire and bridge it over to the hot side of the upper receptacle, and then on the neutral side of the upper receptacle will be our actual neutral. So that being said, I'm going to go ahead and feed these wires through here. Now this 3D print is a bone stock 3D print, meaning I didn't edit the STL or the 3D print file. I think it was actually a .3DP file or something like that. What I could have done is I could have made this hole smaller. Probably should have. But what I can do is I've already done this actually. I just drilled some holes, one here and one here. That way I can install a zip tie around this cable to secure it into place. That way it's not flop around loose. You do not want that. So do that, and then later on I will probably fill this in with some silicone or hot glue or something of that nature. But for now I'm going to leave it loose so that way we can begin wiring things up. Okay, so let's go ahead and get started with the light switch. I'm going to begin with the ground connection. Okay, so we've now got this ground installed, and so we'll make sure that we have good metal to metal contact there on this screw connection here. Alright, so next we're going to go ahead and tie in our hot up here coming from this cord. That's going to go up here. Okay, so now we have the hot line coming from the cord secured into place here. Next we'll go ahead and grab our slightly longer hot jumper, or live jumper, hot, live, whatever you want to call it. And everybody has their own preference for what they call this stuff. Okay, so before I go further, I did want to mention there's two ways you can wire this up. I'm choosing to use this light switch simply as an on-off switch for the whole circuit. That way I can plug up my power supply, and then when I'm ready to apply power to it, I just flip the light switch and that turns on power to it. Now what you could do is you could wire as such to where when this light switch is in the off position, you're sending ballasted mains of power to your power supply. But if you want to send full power, you could just hit the switch and bypass the ballasted part of the circuit. However, as mentioned, I'm using this light switch as a simple on-off switch for the ballasted portion. And if I want to use full mains power, then I would just bypass this whole gadget altogether by just using a regular power cord. So that being said, it's going to continue on. I should note that when doing these connections, make sure that you're getting good metal to metal contact everywhere. Like make sure you're not getting insulation sandwiched between the screw and the terminal, because you're not getting a good connection there in that case. So that being said, let's go ahead and run this live over to here, and we'll grab our receptacle, and we're going to go ahead and make a connection here on this side of the receptacle. So we need to back this screw out. Now this receptacle has the option to more or less backstab the wires into place, and this is better than the backstab you'll find on a lot of cheaper outlets or receptacles, because this actually has a mechanical connection where the screw tightens down onto this little piece inside here. But since I've already went through the process of J-hooking everything, I'm just going to go ahead and hook everything up the old-fashioned way. So we'll go ahead and sneak this little guy in there. And then we'll tighten this down. Alright, that looks good there. Okay everybody, so here's where we're going to put the light bulb in the bottom socket in series with the power supply in the top socket. Now with this receptacle, as I mentioned earlier, it has the backstab option, but I'm choosing to use the J-hooks instead. It has these little metal pieces inside there. You want to make sure that they don't come loose from the screw, so that when this is all secured into place, this metal piece there is resting up against, appears to be brass right there. Alright, so we're going to go ahead and connect one of the two sides of this black wire onto the neutral side of the bottom socket. Okay, now we're going to take this side of the wire and we'll go up here. Okay, so again we have switch mains going in here. That goes through the light bulb socket, through the light bulb, which acts as a ballast. And then it comes out on the neutral of this side. It then goes in to the hot connection of the upper receptacle. And of course feeds the power supply. And then we're going to hook up our neutral right here. Okay, so now we did get a little bit of the insulation up in here, but we do have very good metal to metal contact on this. So that being said, let's go ahead and hook up our ground to the receptacle. Okay, so now we have everything wired up. Okay, now we're ready to go and assemble this thing. So I'm going to go ahead and unthread the light bulb from the light socket. Set it to the side. And I'll go ahead and unplug everything from the receptacle. Alright, now let's go ahead and put everything into place here. Now let's go ahead and screw everything in. Okay, we're going to need to line up everything. So let's go ahead and unpackage our wall plate here. Yeah, this is the fun part of dealing with a 2-gang box like this, is getting everything lined up. So we'll see if it stays in place. All right. Alright, we might have stripped the threads out a little bit in the plastic behind here, but it's obviously not coming out. So that being said, let's go ahead and set the wall plate into place. Okay, so now I just need to go ahead and run a zip tie through here to secure this wire into place. That way it's not loose inside here. Okay everybody, so I did a test before I put this all together, but I figured I'm going to do another one on camera just to demonstrate how this works. This is how you can test for proper functionality of this device before you actually plug it into mains power. So what I've done here is I took a power cord, like what power, something like, let's say, a cable box, and over here I have literally jumpered it. I've shorted it out. Do not do this on a power cord or a socket that's getting mains power. It's just dumb. Now I will mention though, in this case, the worst that would happen is this light bulb would light up. That's because the light bulb is acting like a ballast. Right now, for example, I have everything switched off. If I switch on this light switch, you can see we now have a connection of about 23 ohms. Now I should note that light bulbs, incandescent light bulbs, they actually have a higher power draw at first when they're first powered on. When they power up, the current draw is significantly higher than the 60 watt rating of the bulb. However, in the event you have a short circuit in the device you're testing, the inrush current of this light bulb is way less than not having it there. This light bulb will act as your safety fuse. It will limit the current that goes into the device that you're testing. And that's why this makes testing power supplies and small electronics a lot safer. It does not guarantee that you will not damage the device that you're testing. It just limits the amount of current that's there to damage it. Like for example with a computer PSU, they of course have capacitors in them on the primary that do charge up and hold a pretty significant amount of charge. Now for example, we're about to test out this unit on this power supply and I'll demonstrate how it works. Now one other thing I'm going to do to this off camera after this video is I'm going to use either silicone or hot glue or something to just glue around the edge of this wall plate, because of course, as you might be able to see, it's not the most secure. Normally on a wall this will be fine, but in this case we want to make sure this is nice and secure up against the edge of the box. So I'll do that after the video. But anyways, let's go ahead and test this thing. Okay everybody, so now we're going to back porch test this power supply. Now this power supply here is perfectly fine. There's nothing wrong with it. It works fine. But we're just going to simulate how I test PSUs. I back porch test them. So we have our little box plugged in, power supply to it. However, the light switch is off. I'm going to demonstrate what's going to happen when we turn this light switch on. Watch this light bulb. So you see how it briefly come on and went out? It actually current limited this power supply. Now the PSU is actually not turned on and running. It is currently in standby. So you can see the little light there is lit up. So again, this light bulb is ballasting the power to this power supply. Now for example, I'm going to go out here and I'm going to switch this on. Okay, so I'm currently out here with the power supply. I now have the green wire jumper to black, which has powered this unit on. Again, as I mentioned, this unit works fine. So this unit has no load on it, I mean no connected devices, so it's not drawing a whole lot of power. So for example, we can see our light bulb down there is not even glowing. Now let's say if something bad happens to this power supply, let's say the main switching FETs in there short out, or something major happens. What will happen is this light bulb will then take over as a current limiting fuse in a way. Now I should note that, let's say for example something does short in this unit, you would still see a pretty nice little flash in it, because of course you got those high voltage capacitors on the primary that do pack a punch. But as you can see here, the light bulb is not even lit. Now for example, if I switch this off, it just switched off. Now let's go and start this power supply with the green to black shorted. So similar thing, you can see how the light bulb briefly lit up. So again, what this is doing is it is acting as an inrush current limiter in this case, and also it provides short circuit protection to limit the amount of fault current that would travel into this power supply in the event something happens. This will prevent your, let's say, your circuit breaker from tripping. This would prevent your fuse in a power supply from popping, stuff like that. So anyways, that's how you can build a ballasted mains supply for testing stuff like this. Now, for example, let's say you have something you're wanting to test that does draw a bit more power. I don't know. Let's say, I don't know, a guitar amp or something. Something you need at least maybe a couple of amps or so of current. What you could do in that case, instead of using a light bulb like this, you could use any resistive load, like let's say a hot plate. Let's say something that's rated for, I don't know, 500 or 700 watts. That would act as a higher current ballast. It would still allow for that device to work. However, if something was to shorten that, it would still serve the same function as this light bulb. So anyways, alright, so for this video, hope you enjoyed it. Thanks for watching.